Hello there, guys, and welcome to class. We are working on the science subject and week number 6. Let's start with our presentation. Here you have the title and end in mind. Lesson number 4, Erosion and Deposition by Wind, Ice, and Gravity. We have the end in mind, documenting a series of causes and effects that wind, ice, and gravity can have over the processes of erosion and deposition. All right, and here you have the summary of the activities you have to complete today. Number 1, read lesson number 4 and prepare a small presentation about the topic. Share it with the class during the live session, okay? This is something very, very important, please. Make sure to access your online book, read the topic, and then extract the most important information. For your presentation, you can use PowerPoint, Canva, Prezi, I don't know. You can use any of those online platforms for your presentation. Then during the live session, you are going to be sharing about it, so make sure to be ready. That has to be done before our live class. Okay, let's continue. Okay, so let's jump into our topic. And today we have, how can wind shape Earth? And well, today is going to be very interesting because we already completed an experiment before. You remember? Where we were actually applying wind, we were applying ice, also some water. We were observing some changes due to gravity. So today we're going to contextualize and expand the topic a little bit more, okay? So let's start with wind. How does it shape Earth? When wind moves soil, sand, and rock particles, it acts as an agent of erosion. The grinding and wearing down of rock surface by other rock or sand particles is abrasion. Rocks can become smooth and polished from abrasion. So remember when you had your straw last week and you were just, blowing different sand and particles away. So basically that is what we will observe as erosion and abrasion. Okay, let's continue. So the removal of fine sediment by wind is called deflation. Like when we remove those very small particles of sand, that is a deflation. Desert pavements results when wind carries soil and fine sediment away from an area, leaving only pebbles and small rocks behind. Okay. And how does a desert pavement form? Think about it. So I was explaining to you a little bit about the process of abrasion, the process of erosion. So how can we relate that to the picture that we see right here? How does wind will change the structure from the picture on the left to the picture on the right? Think about it. Think about it. And we're going to discuss about this in our live session. Okay, now we have a very important word, which is dunes. And they are mounds of wind-deposited sand, common in deserts and along the shores of lakes and oceans. Dunes usually move in the same direction the wind is blowing. A dune's gently sloped side usually faces the wind, which moves material up this slope. Sand moves over the crest and slides down the steep face. So going back to our experiment last week. So remember you were blowing away some sand. So at the end, that type of sand will be deposited right at the bottom of your container, right? And we will be actually able to observe that it is following the direction of the wind. That is why we will classify it as a dune. Okay, and we have another question here. Why is the slip face of a dune is steeper than the windward slope? So you can notice here we have the slip face, the wind direction, wind and sound, and the direction of the dune movement. Okay, so of course, we will have to apply way more wind to our experiment last week in order to generate a dune like this one. But the principle is pretty much the same. Okay. Now let's continue with loess, which consists of thick deposits of wind flow, fine-grained sediments. So grains are like small rocks. So if a lot of rocks are deposited in a certain place, then that is going to be a loess. Loess deposits can be found far from their original source and can build up over thousands or millions of years. Imagine, it takes millions of years for a loess to form. Loess forms good soils from growing crops. Okay, now we're going to leave a little bit of wind behind, and this time we are going to focus with ice. Remember, we were using ice in our experiment last time. And the equivalent of the ice to the natural world are going to be glaciers. So a glacier is a large mass of moving ice that forms by the compacting of snow by natural forces. Glaciers move downhill by gravity and cause erosion as a glacier melts and deposits the materials it carries. And we have another important word, which is glacial drift. It's a general term for all materials carried and deposited by a glacier. In our experiment last week, remember that after a while, the ice started melting. And when it was melting, it was moving from one place to another. Also, it was already leaving some water on the soil, and then it was moving the soil as well. So that is what we are going to know as glacial drift. And an alpine glacier is a glacier that forms in a mountainous area. As a glacier flows down a mountain, it can erode a V-shaped valley caused by a stream into a U-shaped glacier valley. An alpine glacier can carve out bowl-shaped depression called cirques at the head of a valley. This is a little complicated of a word, but it is cirques. And a sharp ridge called an arete forms between two cirques that are next to each other. Don't worry, we're going to take a look at a picture so we understand a little bit better all of this information. When three or more aretes join, they form a sharp peak called a horn. Okay. Incontinental glaciers are thick sheets of ice that may spread over large areas, including across entire continents. Imagine there are pieces of ice that are basically covering like large parts of continents. And when they move, is what we know as continental glacier. And continental glaciers flatten and smooth the landscape. Erratics and kettle lakes are landforms produced by continental glaciers. Okay, now everything is going to start making sense a little bit better with this picture. So here we have the types of glaciers, and well, first of all, we have a Piedmont Glacier. Just like you can notice, this Piedmont Glacier comes right from the top of a mountain, and then it goes all the way to the bottom of the same mountain. That is a Piedmont Glacier. Here we have a Cirque Glacier, which is located right over here at the top. It's just like a body of water that is frozen right there. And also we have a valley glacier. In this valley glacier is somewhat similar to the Cirque Glacier, but the difference is that it's a little bit longer, let's say. It is longer than the Cirque Glacier, but it's going to be smaller than the Piedmont Glacier. And here we have an example of a continental ice sheet, or a continental glacier, which is a very large piece of ice that is covering a large piece of land. Okay. And now we're going to talk about melting the ice. During the last ice age, an ice dam held back the water of glacial Lake Immishuala. The dam broke and emptied the entire lake within 48 hours, forming huge waterfalls, deep canyons, and tall ripple marks in the land. That is something very nice. So imagine when all of this ice was melted, then it even formed waterfalls around. Lake Missoula reformed and flooded about 40 more times. Okay, now let's leave ice behind, and now let's just stay with gravity. How can gravity shape Earth? Gravity influences the movement of water and ice. Gravity also moves rocks and soil downslope. Mass movement is the shifting of material due to gravity. Creep is the extremely slow movement of material downslope. So let's think about a mountain. So we are going to have many different rocks and many different materials. And you know that gravity is affecting them, right? But little by little, they start coming down. So that's what we know as creep. Rapid mass movements usually happen on steep slopes and are the most destructive. A rock fall happens when loose rocks fall down a steep slope. A landslide is the sudden and rapid movement of a large amount of material downslope. Okay, so basically, if a lot of material starts coming down due to gravity, that's what we know as landslide. Okay, and also we have a mud flow. It's a rapid movement of a large mass of mud. Mud is like water mixed with soil. So when water mixes with soil and it starts moving from one place to another, that's what we know as mud flow. Mud flows happens when a large amount of water mixes with soil and rock. Deforestation, volcanic eruptions, and heavy rains can all create mud flows. And here we have an example of what it looks like when the soil or the mud flow is taking place. It is being attracted by gravity, and of course, all of the land starts deteriorating. And right, that's it for today, guys. I will see you in class. Remember to prepare your presentation, please. Take a look at the topic of your online book and prepare a PowerPoint, a Canva presentation, because you are going to share it with us in a moment. That'll be about it. Goodbye, guys. Take care.